Hi guys, this is the EdExcel GCSE 91 Maths Paper 2 from the Foundation Papers, and it's from the November 2019 series. Question 1. We have to write these numbers in order of size. We have to start with the smallest number first. Well, to do this question, we can think of these numbers as temperatures. The more negative a number, the colder it is. We begin with the -7, followed by the -4, followed by the -2, followed by the 1, followed by the 8. Question number 2, we have to write the number 8,375 correct to the nearest thousand. Well, the 1000 column, that corresponds to this 8. The digit after it, which is this 3 over here, this is less than 5, so we don't need to round up the 8 to the next digit. So to the nearest thousand, we have 8,000. Question 3, we have to write 0.23 as a percentage. Well, percentage simply means out of 100. So we have over here 23 over 100, which is the same as 23%. So here we end up with 23%. And now for question 4, we have to find the value of the square root of 17.64. So for this question, we have the square root of 17.64. You'd find that to be 4.2. So we have plus minus 4.2. Don't forget the plus minus. The reason for that is when we square root, we end up with 2 solutions. Question 5, we have to find the value of 6 to the power of 5. Input this into our calculator. We have 6 to the power of 5. It turns out we get 7776. Question number 6. There are 14 rows of seats in a cinema. There are 15 seats in each row. A film was shown in the cinema on Saturday. Each ticket for the film costs £6.50. The tickets that were sold cost a total of £1,274. How many tickets were not sold? Well, we can find out the number of tickets sold by considering that each ticket cost £6.50 and there were £1,274 worth of tickets sold. So therefore the tickets sold, we have over here 1274 divided by £6.50, and if we work this out, 1274 divided by 650, it turns out we get 196. So you can see here there are 196 tickets which are sold, and therefore you can see here the total number of seats available. So seats available in the cinema, we have 14 times by 15, which is 210. So 196 tickets were sold, which means 196 seats were taken up, and therefore the number of tickets not sold, that's equal to the difference between these. So we have 210 minus 196, which is 14. So we have 14 tickets which were not sold. Question number 7. Harry has 20 sweets. He gives 7 of the sweets to Nadia. What fraction of the 20 sweets does Harry have now? Well, over here, Harry has now, well, he began with 20 sweets, he gave 7 of them away, he has 13 sweets left over, and therefore he had 20 to begin with, and he has 13 left over, so the fraction is 13 over 20. Question 8, here is an input machine, so we input a number, we multiply by 8, we subtract 5, we get an output. We have to work out the output when the input is 6. So if the input is equal to 6, we multiply 6 by 8, and then we subtract off 5, So here you can see we have 48 minus 5, which is 43. So the output when the input is 6 is 43. And now for part B of the question, here is a different number machine. We have some input, we add 13. There's another rule over here and we get an output. When the input is 17, the output is 10. Complete the number machine. Well, if the input is 17, we then add 13, and then after this we follow some sort of an instruction, and then we get an output of 10. So here we have 30 followed by some sort of an instruction, and we get 10. Well, to go from 30 to 10, we can either divide by 3 or subtract 20. So therefore, we can either divide by 3 or we can subtract 20. It doesn't make a difference. You'll still get an output of 10. So I will put down divide by 3. Question number 9. Here is a list of numbers 6, 4, 8, 9, 4 and 3, and we have to work out the median. The first thing to do is write the numbers in ascending order. So we start off with the 3. We have 4, 4, 6, 8 and 9. Now you can see here the middle number will lie somewhere in between the 4 and the 6. So therefore the median is equal to 5. And now for part B of the question, I should pick at random one of the numbers. What is the probability that she picks an odd number? Well, you can see over here we've got 6 numbers in total, and of those 6, the 3 is odd and the 9 is odd. So we have 2 numbers which are odd, and simplifying this fraction we get 1/3. For part C of the question, Clara has 5 cards. There is a number on each card. 2 of the numbers are hidden. So we've got so far the numbers 3, 8 and 5, and we've got 2 hidden numbers. The mode of the 5 numbers is 3, and the mean of the 5 numbers is 5. We have to work out the 2 numbers that are hidden. Well, the mode, that means over here most common. So if 3 is the most common, let's have another 3. So far we've got 3, 3, 8 and 5, and some other number we'll call this x. And what we know is that the mean of the 5 numbers is equal to 5. So to work out the mean, we add up all the numbers and we divide by the total number of pieces. So if we add up all these numbers, so we have 3 plus 3 plus 8 plus 5 plus x, and then if we divide by the number of pieces, we have 5 pieces. It turns out here we get 5. Of course 5 is our mean. So if we tidy up on the top, 3 plus 3 plus 8 plus 5, that's 19. So we have 19 plus x over 5 equals 5. If I multiply both sides by 5, these cancel out, so we have 19 plus x equals 25, and now if I subtract off 19 from both sides, you can hopefully see x is equal to 6. So our other number is 6, so we have 6 and 3 as our numbers. Question number 10. Here is the charge at a car park in Spain. So the car park charges 0.024 euros per minute. John has parked in this car park, and then he drove into the car park at 10:45. When he drove out of the car park, he has to pay €8.40. At what time did John drive out the car park? Well, we can find out the total number of minutes he stayed in the car park. So the number of minutes in the car park, we have 840 divided by 0.024, and if we work this out, 840 divided by 0.024 it turns out we get 350 minutes. So he's staying in the car park for 350 minutes. He arrives at 10:45 AM and he's staying for 350 minutes. Now, it will be easier if we convert this into hours. Now, just as a side point, to go from minutes to hours, we would have to divide by 60, and of course, hours to minutes, we have to times by 60. So, if we divide 350 by 60, it turns out we get 5 5/6 of an hour. So we have 5 5/6 of an hour. Now this 5 5/6, we can convert that into minutes by multiplying by 60. So that's the same as 50 minutes. So we have over here 5 hours and then 50 minutes. So we have 10:45 AM plus the 5 hours, 50 minutes. And if we work this out, it turns out we get 16 hours, 35 minutes in the afternoon. So we have 16:35 PM. Question 11, you can use this graph to change between stones and kilograms, and for part A we have to change 3 stones into kilograms. So to do this question, well, we have 3 stones, so let's draw a vertical line up, and then from here we draw a horizontal line across. It turns out we get 19 kilograms. And now for part B we have to change 80 kilograms to stones. Couple of ways of doing this. One way is to recognize that if we have 3 stones, which is equal to 19 kilograms, we can use this to find out what, well, actually, the easiest way is to find out what, no, yeah, we're right. We have 3 stones, which is equal to 19 kilograms. So therefore, we can find out what over here 1 kilogram is. So to find out what 1 kilogram is, we have to divide by 19. So 3 divided by 19, you'd find that to be 3 over 19, which is 0.15, etc. So here, 0.15 stones would represent 1 kilogram. So let's just move this. And therefore, to find out what 80 kilograms is, we would have to multiply by 80. So this number times by 80, that is 12.6 stones. So here we have 12.6. Question number 12, we have to find the number that is exactly halfway between 1/10 and 3/5. So to do this question, we can essentially find the average of those numbers. So we have 1/10 plus 3/5 divided by 2, and if we work this out, well, 1/10 plus 3/5, that's 7/10. So here we have 7/10 divided by 2. So if I divide this number by 2, we get 7 over 20. So we have 7 over 20, and as a decimal, that's 0.35. So we have 0.35. Question number 13. On the grid we have to draw an enlargement of the shaded shape with scale factor of 3. Well, quite straightforward. You can see here we have a length of 2. So when we come to stretch this one by scale factor 3, this one will have length of 2 times by 3, which is 6. So we want 1, 2, 3, 4, 5, 6. This has length 2, so we want to go up by 6 as well. So we have 1, 2, 3, 4, 5, 6. And then here we've got 1 across and 3 up. So here we want to go 3 across and 9 up. So we have 3, 6. So here we have 3, 6, and then 9, somewhere here. And then we join this up over here, and that's our enlargement. Now for question 14, a shop sells compost in 20 litre bags and in 40 litre bags. One day the shop has had 2 special offers for the compost, as we see here. 20 litres for this in this bag, and 2 bags are for £3.50. And for this bag, which has 40 litres, 3 bags cost £9. And which offer is the better value for money? You must show how you get your answer. Well, over here, if we get 2 bags, 2 times by 20, that's 40. So we get 40 litres for £3.50. And over here, we get 3 bags for £9. 1 bag has 40 litres. So here we have 3 times by 40, that's 120. So we have 120 litres for £9. And we can find out over here how much it costs for, say, 10 litres. So 350 divided by 4. So let's just work this out. 350 divided by 4, that's 0.875. And 9 divided by 12, that's 0.75. So you can see over here that in conclusion that the 40 litre bag is better value for money. Question 15. The length of a plane is 19.2 meters. Lucas buys a scale model of the plane. The scale of the model is 1:24. We have to work out the length of the scale model of the plane. Give your answer in centimeters. Well, to go from meters to centimeters, we would have to multiply by 100. Centimeters to meters, we would have to divide by 100. So this 19.2 times by 100, that's 1920 centimeters. And therefore, using the scale, you can see over here, 1920 divided by 24, you'd find that to be 80. So we have 80 centimeters as the scale length of the plane. Question 16. Maria invests £4,500 in a savings account for 3 years. The account pays simple interest at a rate of 1.8% per annum. We have to work out the total amount of interest Maria gets by the end of 3 years. So over here, if we have 1.8% per year and we're investing for 3 years, you can see here 1.8% multiplied by 3, that's equal to 5.4% for the 3 years. Okay, so we need to work out 5.4% of this amount over here, which will tell us the amount of interest. So therefore, 5.4% of £4,500. So all we have to do over here, 5.4 divided by 100 times by 4,500, that's equal to 243. So we have over here £243. Question 17. ABC is a straight line, as we see here. AB is equal to BC, which is equal to BD, and the angle DAB is equal to 64 degrees. We have to work out the size of angle marked X. Give a reason for each stage of your answer. Okay. Well, what you can hopefully see here, if look at this triangle here, the triangle ABD, if AB is equal to BD, we have an isosceles triangle. So the base angles on an isosceles triangle are equal, so this angle over here is equal to 64 degrees. So let's just add that reason in. We see that the angle ADB, that's this angle, that's equal to the angle DAB, which is equal to 64 degrees. And the reason for this, so the base angles on an isosceles triangle are equal. And we can see from here the angle ABD, so the angle ABD, that's equal to 180 minus 64 minus another 64, which is equal to 52. The reason for that, angles in a triangle add up to 180. So this angle over here is 52 degrees. So the angles in a triangle add up to 180. Well, with this, we can also find out the angle DBC. So the angle DBC, that's going to equal 180 minus 52, which is 128. So this angle over here is 128 degrees because we have angles on a straight line which add up to 180. As we see over here, so angles on a straight line add up to 180. And we can also see over here that the angle BDC, so BDC, that's equal to the angle DCB, which is also equal to x. So this angle over here is x degrees. The reason for that is, again, the same as this reason over here. So let's just copy and paste this. So base angles in an isosceles triangle are equal. Now, we should know that angles on a triangle add up to 180. So we have x plus 128 equals 180. So again, let's just copy and paste this reason over here. Angles on a triangle add up to 180. So here you can simplify this. 2x plus 128 equals 180. We can tidy this up by subtracting 128 from both sides. So we have 2x, which is equal to 52, and therefore if we divide both sides by 2, you can see x is equal to 26. So x is equal to 26. Question 18. Ben is n years old, Chloe is twice as old as Ben, and Dan is 5 years younger than Ben. The total of Ben's age, Chloe's age, and Dan's age is t years. We have to find a formula for t in terms of n. Well, if Ben is n years old, Chloe, she's twice as old as Ben, so her age is 2n, and Dan is 5 years younger than Ben, so Dan is over here n minus 5. So the total age t, that's equal to n, which is Ben's age, plus 2n, which is Chloe's age, plus n minus 5, which is Dan's age. So therefore, you can see here, we have 4n minus 5. So t is equal to, over here, 4n minus 5. And now for part B, we have to put a tick in the box which is next to the identity. Well, technically all of these are wrong because an identity should have 3 lines. But whatever is on the left hand side must be the same on the right hand side. So over here, this is an equation, this over here is an expression, this here is a formula, this here is an inequality, so this here is an identity. And technically we should have 3 lines, like so. Question 19, here are the ingredients needed to make 16 biscuits. So to make 16 biscuits we need 175 grams of butter, 75 grams of sugar and 250 grams of flour. Anna has 500 grams of butter, 300 grams of sugar and 625 grams of flour. We have to work out the greatest number of biscuits Anna can make. So the way to do this is to think about a scale factor. So if we take a look at our butter, we have 500 divided by the 175. So if we work this out, it turns out we get 2.8 0.85, etc. Okay, if we think about the sugar, we have over here 300 divided by 75. So if we work this out, 300 divided by 75, that's 4. And if we think about the flour, we have 625 divided by 250, which turns out to be 2.5. So why is this important? Because what you can see over here, she's limited by the amount of flour she has, and therefore the amount of biscuits she can make is 16 times by 2.5, which is 40. So she can make 40 biscuits. So we have 40 biscuits here. Question 20. An estimate for the height h meters of a tall building can be found using this formula. H equals 4f plus 12, where the building is f floors high. A tall building is 110 floors high. The real height of the building is 442 meters. Seb uses the formula to find an estimate of the height of this building. He then finds the difference between his estimate and the real height. Show that this difference is less than 5% of the real height. So we can find the estimate. So h, that's equal to 4f, so we have 4 times by 110 plus the 12, so that's 452 meters. So this is the estimate of the height of the building. We know that the real height is 442, so therefore the percentage difference, that's equal to, well, here we have 452 minus 442 divided by 442 multiplied by 100. So here we have 452 minus 442 divided by 442, and then if I multiply this by 100, it turns out we get what do we get? So we get over here 2.26%. So here we get 2.26%, which is less than the 5%. And that's what we have to show. Next question. The table shows information about the weights of 50 potatoes, as we see here, and Iveta drew this frequency polygon for this information, and the frequency polygon is not correct. We have to write down 2 things that are wrong with this frequency polygon. So we see here there's there's no frequency label. So that's along this axis here, and the frequency polygon should not be close, so we should not join these with a straight line. Question 22. The length of a pencil is 128 millimeters to the nearest millimeter, and we have to complete the error interval for the length of this pencil. So if it's to the nearest millimeter, we have our original length 128, and then we have plus minus a half of the unit, so we have a half of the 1 millimeter. So this is equal to 127.5 and 128.5. So therefore we have 127.5 and 128.5. Question 23. Tom and Adam have a total of 240 stamps. The ratio of the number of Tom's stamps to the number of Adam's stamps is 3 to 7. Tom buys some stamps from Adam. The ratio of the number of Tom's stamps to the number of Adam's stamps is now 3 to 5. How many stamps does Tom buy from Adam? You must show all your working. So if we consider the situation before, you can see here that there's 3 plus 7 parts. So you can see here that there's 3 plus 7, which is 10 parts. And here we can find out how many we have per part by dividing the 240 by 10. So 240 divided by 10, that's equal to 24. So here we have 24 per part. So Tom, he had 3 times by 24, which is 72 stamps, and Adam, he had 7 times by 24, which is 168 stamps. And the situation after, well, we have 3 plus 5 parts, so here we have 8 parts, and then 240, because the number of stamps remain the same as 240, 240 divided by 8, that's 30, so we have 30 stamps per part. And then Tom, he has 3 times by 30, which is 90 stamps, and therefore Adam, he has 5 times by 30, which is 150. 150 stamps. So you can see Adam has lost 18 stamps, whilst Tom has gained 18 stamps, and we can confirm that by working out the difference. 168 minus 150 is the number of stamps Adam lost, which is coincidentally the same as the number that Adam gained. 90 take away 72, which is 18. So we have 18 stamps which Tom bought from Adam. Question 24. Each person in a fitness club is going to get a free gift. Stan is going to order these gifts. Stan takes a sample of 50 people in the fitness club. He asks each person to tell him the gift they would like. The table shows information about these results. 17 want a sports bag, 7 want a gym towel, 11 want headphones, 15 want a voucher. There are 700 people in the fitness club. Work out how many people, how many sports bag Stan should order. Well, the proportion of those who want a sports bag, that's 17 over 50. And we multiply this by our total number, which is 700. So here 700 divided by 50, I'll just get a calculator. So 17 over 50 multiplied by 700, you'd find this to be 238. So the number of sports bags he should order is 238. And for the next part, write down any assumptions you made and explain how this could affect your answer. So the sample is representative, otherwise the answer would be wrong. Question 25, here are 6 graphs. So we have the graphs A to F, and we have to write down the letter of the graph that could have the equation for the first part, y equals x cubed. Well, quite obviously that's graph F. So we have F over here, and for the next part, y equals 1 over x. So 1 over x, that's this graph D. Okay, now for question 26, the nth term of a sequence is 2n squared minus 1. The nth term of a different sequence is 40 minus n squared. We have to show that there is only one number that is in both of these equations. So I think the best way to approach this question is just by listing the different terms in the sequence. So if we begin with the 2n squared minus 1, we can go to our calculator to the table function. As soon as I find the table function. So if I type this in, so we have 2x squared minus 1. We can start at 1 and let's list the first 20 terms. Actually, should we do that? Actually, let's just list the first 10 terms actually. So here you can see we have terms 1, 7, 17, 31, 49, 71, 97, 127, 161, 199, and we could continue. Now if we think about the other sequence, 40 minus n squared, if we list the terms here, so if we have 40 minus x squared, again listing the first 10 terms, we have over here 39, 36, 31, 24, 15, 4, minus 9, minus 24, minus 41, and minus 60. Now, if we continue, the terms will just get more and more negative. So there's only going to be one number which matches up, and that is the 31. Okay, so therefore 31 is the only number in both sequences. Now question 27, we have to work out 3.42 times 10 to the minus 7 divided by 7.5 times 10 to the minus 6. Well, if we just type this into our calculator, so we have 3.42 times 10 to the minus 7 divided by 7.5 times 10 to the minus 6. You can see here we get 0.0456. But we want to put this into standard form. And for us to put this in standard form, we need to recognize standard form, that's in the form a times by 10 to the power of n, where a is in between 1 and 10. So essentially we need to move the decimal place 2 places to the right. So here we have 4.56 times 10 to the minus 2. We've moved it 2 places to the right. Question 28. The number of days d that it will take to build a house is given by this equation here. D equals 720 over n, where n is the number of workers used each day. And Ali's company will take 40 days to build the house, and Haley's company will take 30 days to build the house. Haley's company will have to use more workers each day than Ali's company. How many more? Well, if we consider how many days Ali used, D is equal to 720 over 40, which is 18 days. And if we consider Haley, the number of days is equal to 720 divided by 30, which is 24 days. And therefore, the number of workers each day is, sorry, this is actually, if we be a bit more technical with our units, this is workers per day. Okay? So therefore, the difference between these, 24 minus 18, that's equal to 6. So we have 6 workers per day. Question 29. The diagram shows a cube and a cuboid, and you can see the cuboid has dimensions 6 by 8 times 18. The total surface area of the cuboid is equal to the total surface area of the total surface area of the cube. That's equal to the total surface area of the cuboid. And Janet says the volume of the cuboid is equal to the volume of the cube. Is Janet correct? You must show how you get your answer. Well, the first thing we can do is find out the surface area of these shapes. We can find out the surface area of the cuboid first of all, and if we find out the length over here, say x of the cube, obviously it's a cube, it has the same length everywhere, we can find out the volume here, and we can also find out the volume here, and if they're not equal, then she's incorrect. Let's first of all find out the surface area. So the surface area of the cuboid, that's equal to, well, here we have 2 times by 6 times by 8. So this 6 times 8 gives this and this over here. And then we also have 2 times by 8 times by 18. So this over here would give this bottom shape over here plus this top shape over here. And then also we've got 2 lots of 6 times by 18. So that gives this side face here, and also this front side face here. So the surface area of the cuboid, we have 2 lots of 6 times 8 plus 2 lots of 8 times 18 plus 2 lots of 6 times 18, which is 600. So we have 600 centimeters squared, and therefore the surface area of the cube is equal to 600 centimeters squared. Okay, now why is this important? Well, the surface, we can use this to find out the length of x by recognizing that we have 6 lots of x squared, which is equal to 600, because the area of one face is x squared, so the area of 6 faces, that's going to equal 6x squared. So this is equal to 6x squared, so 6x squared is equal to 600. Okay, so if we use this information, we can divide by 6 on both sides. So we have x squared is equal to 100, and therefore x is equal to 10 centimeters. So this is the length of the cube. Okay, so in other words, we have 10 centimeters by 10 centimeters by 10 centimeters, and therefore the volume of the cube, that's equal to 10 cubed, which is 1000 centimeters cubed, and the volume of the cuboid, that's equal to 6 times by 8 times by 18. So if I work this out, 6 times by 8 times by 18, you'd find that to be 864 centimeters cubed. And clearly these are not equal, and therefore this person is incorrect. Question 20. Here are 2 column vectors. We have A, which is equal to 5, 2, and B, which is equal to 3, minus 1. And on the grid below, we have to draw and label the vector A minus 2B. Well, I think it will help us all to first of all visualize what this is saying. First of all, if we draw the vector A 5, 2, so 5 across, so that's 1, 2, 3, 4, 5, 2 up. This over here is the vector A. The vector B, that's equal to 3 minus 1. So if we draw that vector, we have 3 across, minus 1 down. So this here is the vector B. And notice how I use arrows. So the vector A minus 2B, if we work this out, we have A, which is equal to 5, 2, minus 2 lots of B, so we have 2 lots of 3 minus 1. So here we have 5, 2 minus, well, 2 times by 3, that's 6. 2 times minus 1, that's minus 2. So 5 minus 6, that's minus 1. 2 minus minus 2, that's 4. So the vector A minus 2B, that's equal to minus 1, 4. So let's just show this in a different colour. We have minus 1 across and 4 up, so that it looks like this. So this is the vector A minus 2B. Now what's interesting actually is we can essentially copy and paste this. So if we do that, let's just highlight it. So basically this over here is the vector 2B. So we've got A minus 2 lots of this. So we essentially go the other way. So minus 2b, so we go minus 3, minus 1, minus another 3, minus another 1. That takes us, so here we have minus 3, minus 1. That takes us over here, which you can see is the same as this vector over here. Okay, so what I've just shown here is a vector minus 2b. And that makes sense. So we've got a minus 2b, which gets us this vector.